Doing a little 2-4 and 8-1 here in college algebra today. They ask us to, we're solving inequalities. They ask us to solve these inequalities both algebraically and graphically. I'm just going to do the first two algebraically and then the last two graphically and just kind of show you that you can do them either which way. Solve it algebraically means go ahead and do the algebra. So on number 1 right here, they've got this times 4 getting distributed through the parentheses. If everything over here divided by 4 nice and evenly, I would go ahead and get rid of this times 4 by dividing everything by 4, but 5 doesn't go into 4 evenly, 9 doesn't, so I'm going to go ahead and distribute the 4 through. Now. And then you really, it doesn't matter which side of the inequality symbol you move x to. I'm a big believer in moving it to the left side because that's how we read. We read from left to right. So I will subtract 5x from both sides. 7x minus 8 less than or equal to negative 9. Right? Add 8 to both sides. 7x less than or equal to negative 1. Correct? And then divide by 7. Sometimes you got to switch that symbol though. When do you have to switch that symbol? Divide by a negative. We are not dividing by a negative. Even though our answer, our solution, comes out to be negative, we don't need to switch that symbol. They want us to graph our solutions on the number line so you can sketch one off to the space that you have available. Negative 1/7, I'm going to go with negative 2, negative 1, 0, 1, and 2 on my number line. And negative 1/7 somewhere about here. I'll put a closed dot, or if you wanted to, you could put a bracket there instead of a closed dot, and then actually put negative 1/7 on the number line, and then go in this direction. Just a refresher of what we're doing to solve an inequality. There's an infinite number of answers to this. Where are the answers, though? Any number that's less than or equal to negative 1/7 would make this a true statement up here. That's what we're finding. On number 2, I'm also going to solve it algebraically. I'm going to get rid of those nasty fractions by multiplying every term by the least common denominator. Out of 2 and 5, what would you multiply by? 10. So let's take everything times 10. Since we picked a multiple of these denominators, you can ask yourself, how many times does 2 go into 10? And you need to take 5 times that entire numerator. So I'm going to write it like so. 5 times that entire numerator. Symbol does not switch because I am not multiplying by a negative number. I'm multiplying by a positive number. 5 goes into 10 twice. 2 times 18, 36. Y'all cool where I got the 36 from? Then distribute to 5. I would get rid of it if I could, but 36 does not go in, or 5 does not go into 36 evenly, so I'm going to go ahead and distribute. 5x minus 25 less than 36. And then continue solving. That would be a 9 and a 5, right? 59? Is that what we're getting? No, 61. My bad. What the heck am I thinking? How about 61? And then divide. That doesn't come out nice. So I do not need to switch the symbol, though, because I did not multiply or divide by a negative. 61/5, if you're not sure what that is, take 61 divided by 5. And it's like 12.2, right? So graph it on the number line somewhere. Got to be between 12 and 13. So 10, 11, 12, 13, 14. Open dot. It's like 12.2, so putting 61/5 though. And that was less than, so fatty, boom, fatty. Yep. Solve the double inequality. There's a quick way and a long way. We can use the quick way on these because if you look on the other stuff right here, the stuff not in the middle, any variables over here, any variables over there, yes or no? No way. If there's no variables on the outer boundaries, then we can just do this. We're trying to get x all by itself in the middle. Just like you would solve an equation. Wouldn't you add 5 to both sides first, if you would? Well, there's not both sides. You have to add 5 to all 3 places. So I'll show you baby steps if you want to. You got to add 5 here, you got to add 5 here, you got to add 5 here. All 3 places. To the left, to the middle, and to the right. You don't have to put the baby steps, but 17 plus 5 is 22. Should I switch this symbol? No, because all I did was add something. Isn't these gone now, correct? And you're left with 3x. Less than comes down. 31 plus 5 is 36, right? Now, to get x by itself, wouldn't you divide all three places by 3? So this is 22/3, less than or equal to. I don't have to switch the symbol because I did not divide by a negative. X comes down, less than comes down, and 36 divided by 3 is 12. Cool? And that's it. That's all they asked you to do. This is x has got to be less than or equal to 22/3 and at the same time less than 12. Wow. Yeah. Here's a great question. Might see it somewhere important. A student has taken 4 tests and has earned those grades. If all 5 tests, right, the student's taken 4 tests and they have 5 tests that count the same, what grade must the student earn on the final test so that his course average is a B, that is 80, at least an 80, and less than 90? Okay? First, let's get some basics down. 1, 2, 3, 4. Don't we know 4 of the test scores? And we don't know the 5th one, correct? X equals the 5th test score. X is the 5th test score, what it could be. Cool? They want their test average. You know how to find the average, don't you? Don't you add them all up and divide by how many total? So let's do the work so you can look back and see when you study for your homework quiz next time about how to do this. Don't we want to take 90 plus 88 plus 93 plus 85, right? There's the 4 tests. And what did they get on that 5th test, my friends? They got x. We need to add x to it and divide that by how many tests they totally have taken. How many is that? 5. So real quick, all I did was add up all the test scores, right? Upstairs is nothing but the test scores. Cool? And we want that to be, like this is their test average, at least an 80. So that's got to be greater than or equal to 80 over here. Cool? But less than 90. So less than 90. First, let's realize why we put an equal to bar on this guy. Because if it says at least an 80, then 80 is good, right? Or anything above it. And it says less than 90, plain old less than 90. Cool? Let's do a little cleanup. Why don't you add these numbers together for me real quick, the 90, 88, 93, and 85. How much is all of that? Okay? If you don't want to rewrite this, you could just kind of maybe scratch this out and put 356 right above it. You know, that's 356. Now all we're trying to do is get x in the middle by itself. Here's a nasty divide by 5. How would you get rid of the divide by 5? Multiply all 3 places by 5. So wouldn't that be 400? Less than or equal to 356 plus x less than 450. Right? All 3 places times 5. With me? Then subtract 356 from both sides. Or all 3 places, I should say. And what do we got? 44. Is that right? It's a pretty good chance that this person is going to get a B for their class average. Because what does that say? Their 5th test score, isn't that what this means right here, has to be greater than or even equal to a 44%, less than a 94%. Cool? If they got above a 94, it's very likely that maybe they went up to an A instead of a B. Cool with that. Average, 1, 2, 3, 4. What was the 5th one? I don't know. So we called him X. Next. Yeah. Here's a good one. Deb Cook. I like her. She's given the choice of 2 options. Deb's got options here, right? This is her job. She makes money. Here's your option, Deb. We'll pay you $3,100 every month, right? That's one option you could have. Or we'll give you $2,000 a month plus 5% commission on all the sales that you make. So it sounds like Deb's a saleswoman here, right? You can either get this flat fee of $3,100 a month or $2,000 plus 5% commission. Cool? Good/bad. Depends on what she's trying to sell. doesn't this mean that she's going to have to sell some stuff to really make this a better deal, correct? Because it's $1,100 extra a month. So what we'll do is let's say X is the amount of sales that she makes. X is the amount of sales. And we're just dealing with 1 month here. Let's realize Y. It says what amount must you sell in a month. So they're just talking about 1 month here. That's all we're comparing. Cool? So let's do the easy option. I'll put it on the right side. If she chose the red option, in that particular month, how much would she make? $3,100. It's a flat fee, right? There's nothing that varies on that option. It's like, here you go, Deb. There's your $3,100. Thanks for working this month. Or the other option was she could have had that $2,000, right? Plus 5% commission on all her sales. And percent, we obviously need to change it to a decimal. Isn't that 0.05? Times the amount of stuff that she sold, which is how much? X. And what do we really want to know? The green one, don't we want to know when it's a better deal than the red one? Correct? So we want to know when the green one is greater than the red one. That's what we want to know. Now, we just simply solve for X. So I subtract 2,000. Then you divide by 0.05. And I hope you started to realize through all your years of math that when you divide by a very small number, things will get bigger. What's 1,100 divided by 0.05? 22,000. So what does that say? X is the amount she's supposed to sell, right? For the green deal, to be a better deal, Deb has to sell more than $22,000 worth of stuff every month. Depends on what she's selling, you know. It's like maybe she's selling cars, you know what I mean? So it's like, hey, that's not that big of a deal, whatever. Maybe she's selling pencils. That's a lot of pencils, you know. It's like, so if you have some basic knowledge of how much things cost and how you can figure this out, and they give you time to think when they present you with the deals, if you do a little bit of algebra, it's like, hey, if I could sell more than $22,000 worth of stuff every month, I'm in good shape. But sometimes people have bad months. Maybe your parents are salesmen. All right, back to the back side. Let me get you all a straight edge real quick. All right. Again, just a quick refresher. Just hold on to it. Quick refresher of how to graph a linear inequality. Can you tell that this is linear because all the variables are to the first power, correct? You could graph this if you wanted to because it's in standard form. I think we're much comfortable graphing stuff in slope-intercept form. So how about we subtract 6x from both sides? Symbol does not switch when you subtract stuff to the other side. Y'all cool with that right there? Then we will divide all terms by -3. And when you divide by a negative, the inequality symbol must switch. Y'all cool with that? Then we will graph that as a line. We have to decide if it's a solid line or a dashed line. When there's no equal to bar, what kind of line is that? So start at -4. And the slope is 2. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. I like to put 4 points. Then, of course, put the nice, neat dashed line. That means none of the points on that line actually are a solution to this. That line doesn't count. That's why it's dashed. It's like the open dot situation for you. But we want to shade where all the solutions are. When your inequality is in slope-intercept form, you can just use the symbol to tell you where to shade. Doesn't that say less than, correct? You have two options. It is difficult for students, at least in Algebra 1, to realize where is above the line or below the line. If you look at your y-intercept, aren't all these points above the line and all these points below that line right there, correct? So if this is a less than, we shade below the line. Just use your pencil and give me a light shade on that. There's all the solutions. Means any ordered pair in there satisfies this inequality right here. The only time you can use that trick of look at the symbol is if it's in slope-intercept form, though. In standard form, you have to use a test point, and that's a lot of extra work. Cool? Let's try it again. Solve this system of inequalities. The only way you solve it is by graphing. So let's take the first dude and put him in slope-intercept form. That would be negative 4y greater than or equal to negative 2x plus 12. And just be careful if your symbol should switch. That's the trickiest part about all of this. When you're doing this on My Math Lab, remember how you shade? You go to that paint bucket tool. Do you remember the paint bucket from a long time ago? When you want to shade stuff. Y'all cool with this guy? I'm going to graph him first. Instead of trying to put both of them in slope-intercept form, I go one at a time. I'm going to graph him. So negative 3 is the y-int. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2. Solid line. And then I'm not going to do a full-on shade because I have a whole other inequality. I'm going to do a light little shading just to help my eyes out. Where would you shade in relation to this line, above him or below him? You've got to look at slope-intercept form, above him or below him. So I just do this if I want to go below. I know I'm shading below that red line right there. Just a little visual indicator I need to shade here. Because what we got to do is we got to graph the other one and see where that shade overlaps this shade. So let's put him in slope-intercept form. 3y greater than negative x minus 4. Divide by 3. Sign stays the same. That's negative 1/3 x. Oh, no. Minus 4/3. Right? What I would do is punch that in my graphing calculator and use the table of values to find me some nice, neat points. So let's do that. I'll pause the video. You can do that. Put this in your graphing calculator for a second. So I have typed that in my calculator, people in video land. Now all I'm going to do is go to second table and find me some nice, neat ordered pairs. I can see one right away. Isn't negative 1, negative 1 a nice, neat point on this line? Depends on where your table showed you up at. Did you have this? Negative 1/3 x minus 4/3 in parentheses. Cool? So go to your table of values and find some nice, neat ordered pairs. Negative 1 is a nice, neat ordered pair. 2, negative 2 is a nice, neat ordered pair. And 5, negative 3 was a nice, neat ordered pair. What I'm going to do is do a little quick mental check. When I plotted those 3 points, is my slope a negative 1/3? Down 1 to the right 3, down 1 to the right 3. Did it work out? Okay. So I'm going to connect the dots, solid or dashed line. Dashed. I even wrote that little order as a table. You know, it's up to you. And now I just need to realize where to shade. Read your slope-intercept form version of it. Should I shade above that blue thing or below him? Above. But I also want to shade in the region where the red one was shaded. So that's why I'm going to shade above the blue line and below the red line at the same time. Isn't that where all my solutions are at for this one? Is that all right with you? Memory refresher? When things were nasty, let Mr. Calculator's table of values find you some neat points. Awesome. Now for the fun ones. This is ones that you have done before, but not very many of them, so we'll take as much time as needed for us to understand. They want us to graph this system of inequalities. 1, 2, 3, 4. I apologize for having it at the bottom of the page and the graph itself is up at the top of the page, right? You see that if you look up, but that's just the way it fit. Okay? So here's what I'm going to do first. I'm going to graph these. These are a piece of cakes because only one variable. They are not oblique. Tell me about that green one right there. Horizontal or vertical? Vertical line. So, boom. That's the blue one right here. That's the blue one. It's x equals 0. And since that's x greater than or equal to 0, that's why I have some light shades to the right. That's where x is greater than or equal to 0. Then the other one, the red guy right here, y is greater than or equal to 0. That's a horizontal line. And I need to put above that line because it's still greater than. Right? And I didn't care about any of this over here because it doesn't satisfy the blue thing. So far, so good. Just those two basic ones. Now I'm going to take the top guy and put him in slope-intercept form. That'd be y is less than negative 2x plus 5. Correct? So I will graph him. 5, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Dashed line. And where will he be shaded? Above him or below him? Sorry, I'm getting too fast for you. My bad. I'll slow down. Below. Just slow me down if I go too fast. I'll shade below him. So basically, I'm in here, right? So far, I got this little triangular region where I've got all three places, right? And now I need to graph the other dude. Let's go purple. That would be negative y greater than negative 2x minus 1, right? Because there's a negative in front of there. Y'all with me? Subtracting 2x from both sides. Then I got to get rid of the negative, so I'll divide everything by negative 1. That changes the symbol and changes everybody's sign also. He's a dashed line as well. Y-intercept of 1, rise 2, run 1, rise 2, run 1, rise 2, run 1, dashed line. Correct? And above Mr. Purple or below Mr. Purple? Below. So now, if you're a highlighter person, the final region is all of this stuff right here. To the right of the blue line, above the red line, below the green line, and below the purple line. That's not that bad for you. But now it asks you to do something else. Identify the corners of the region. To identify the corners, let me zoom in. Zoom. That was magical, right? They want to know where all the places of the intersections are with those. So do you see that this is like a corner point right here? Can you tell where that is on the graph? Where is this point? 0, 1. So there's a corner. 0, 1. Y'all good with him? This guy, come on pen, change color. This guy is a corner of my orange region, right? Y'all, I'm looking at the orange region, and isn't this like some sort of corner place? Where is he located at? 1, 3, is that right? So comma, 1, 3, it's a corner point, right? Obviously, this guy, sorry, I kind of jumping around, isn't that a corner of the region right there also? Where's he at? 0, 0. Cool. So let me label these just so you can see. Here's A. This was, let's call him C, and this is B. A, B, C so far. Question, is this guy a corner of the orange region? No. How about this guy right here? Is that a corner of the orange region? So let's call him D, and oh dear, he doesn't come out as a nice little pretty place. So that's why I also have colors. What you probably should have done, and what I probably should have told you, was like when you graphed these, call this one y less than negative 2x plus 5, like put their names next to them, or call this 1, 2, 3, 4 would probably be simpler, and this is number 1, this is number 2, this is number 3, and this is number 4, correct? Isn't this where the green one and the red one intersect at, correct? So I could use my graphing calculator to figure out where the green one, which is this, and the red one, which is this, intersect, or I could just use plain old algebra. Isn't the green one, if we got rid of the inequality stuff and used equations instead, isn't it like y equals 0, and this is like y equals negative 2x plus 5, and I could substitute, isn't y 0, right? Couldn't I put 0 in for y into this equation and see where they are equal? So I will do that. Since this one's y equals 0, correct, and this one's y equals 2x plus 5, I am solving a system by substitution. The system that I'm looking at is I want to know when y equals 0 and y equals negative 2x plus 5 are equal to each other. Well, since I have a variable all by itself on one side of the equal sign, Where there's a y, I could substitute 0 in its place. So I will subtract 5 and divide by -2, and x equals 5 halves or 2.5, whatever you want to put. If you was to guess, I bet you would have guessed 2.5, but a guess isn't good enough. If it doesn't intersect, if the corner doesn't happen at a nice, neat, coordinate place, you need to show me a little bit of algebra. And which one was it? It was the red one and the green one. So my ordered pair is it 2.50 or 0, 2.5? It's at 2.50, because remember, y was 0. Yeah? All right. That was fun. Uh-oh. What's the problem here, baby? What don't you like about this one besides everything? First one's not linear. Do you know what it would be? It's a parabola, correct? The way we're going to do it is let our graphing calculator help us, right? Let our graphing calculator help us. But let's get y by itself first. Nasty. Nasty, nasty, nasty. Then I'm going to go to my calculator and type that in. So, video people, sorry, I should have switched the sign right there. My bad. And then I type that in. I don't care about seeing a graph of it. I want a table of values. Don't I have to plot some points? So let's get a table of values. Second table. And I also really care about where the vertex is, so maybe I'll go to a graph, maybe I won't. You know, to find the vertex. The vertex, I can't see where he's at a nice, neat place that well. Well, yeah, I do. I can see it in this table. Give me a second to write on this. Well, I won't write on it, but still, do you see that you have symmetry around this point 0, -1.3 repeating? Because this is a -1, that's a -1. That's a 0, that's a 0. That's a 1.6 repeating, that's a 1.6. You see the symmetry around that point? So that tells you that that's the vertex. But what is that as a fraction? That's 0, -4/3, or -1 1/3, right? So let's make a little table of that information. There's my table. Same table that's right there. And I left out all the nasty points except for the vertex. The vertex is the one point that you must have on your parabola. Everything else, I just went and found nice, neat places. -1, -1 was a nice, neat place. -2, 0 is a nice, neat place. And then I skipped over the nasty one, and -4, 4 was a nice, neat place. What if I didn't know where the vertex was by reading the table? You zoom 6 it, because you know we're graphing it on the standard window anyway. You second calculate where the minimum is at, and that will tell you where your vertex is. Cool? It's whatever you need to do there. Now, let's plot these points, but don't connect them very quick. All right, let's just plot them. 0, -4/3, you're going to guess. That's at -1 1/3, so that'd be about like right there. And then the rest of them are nice and neat. -1 there. 2, 0 there, 4, 4 there. Plotting points. The thing is, it's just like with our solid line or dashed line when we're graphing a parabola. This is a greater than, which does not have an equal to bar, so you connect these together with a dashed parabola instead of a solid parabola. Thanks. 4, 4. That one is on 3. Dashed parabola. Where would you shade? Above him or below him, since that's a greater than? So that's, look at the vertex is what you really should do, and go above that. That's inside the parabola. Well, that's where he's lightly shaded, in there. Always related around your vertex. Above, in there. Cool. The other guy, he's linear. Thank you, Mr. Linear. Let's graph him. I'll go blue. That would be 3y less than -2x plus 4. Y, don't have to switch the symbol, -2/3 x plus 4/3. Again, Mr. Nasty, y-intercept. Punch them in, find you some nice, neat points with your table, and let's plot those nice, neat points. You really only need to find two, right? It's a line. You know this is linear. I found myself two nice, neat places on the old table of values. Wrote them down as a baby table, and then I graphed those as a dashed line because it does not have an equal to bar. Once I found those 2 points, I plotted them, and then I know the slope is negative 2/3, correct? So I just rows and run, like up 2 to the left 3, up 2 to the left 3. I found, all you got to do is find 1 point, to be quite honest with you, and then use the slope to do the rest of them. Where would you shade, above him or below him? Below, so we got to shade for our final in the real region. That is where the solutions to this linear inequality is. Cool? You could have also done this. I will show you something on your graphing calculator. If you have them both in your graphing calculator, which I do, and you know where the symbol are, because y is all by itself. If you go back to our cool little hover thing to the left right here, on the first one, wasn't that a greater than, which means you shade above, correct? If I go back to him and I hit enter, that makes it thick. If I hit enter again, you see how it fills up that whole upper right-hand corner? That shades above. And the other guy, where do we want him shaded? Below. So if I hover, 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 see how that goes to the bottom corner right there? That will shade below. Now if I graph it, it will shade it for me also. There's the first one, shaded above. There's the second one, shaded below. If you have a TI-84 color, it will shade them in different colors so you can see where they're at. If you do not have a color, it will do it in black and white. And you have to see, you see the first ones were vertical, the second ones were horizontal. You see the final answer is where you got vertical and horizontal overlapping each other if you wanted to. Next one.